Sample circuit number 6 talks about controlling an LED through a different circuit-based control method, in this case a photoresistor. A photoresistor is a circuit element whose resistance changes depending on the amount of light it receives. So let's head over to the schematic for this particular circuit. The components that we have are our output LED and its current limiting resistor, our photoresistor, which in this schematic is this guy down here, whose resistance will vary depending on how much light's shining on it, and a resistor that pairs with that to create a voltage divider, because our Arduino can only measure voltage, not resistance. So when I connect those in series and then read the point in between them, that will give me a voltage value that varies depending on the current resistance of my photoresistor. So if we start hooking everything up, we'll start with the output side, and port 9 is going to connect to our output LED, connect to its limiting resistor, and then that connects back out to ground. For our control side, we're going to have 5 volts out. It's going to be connected to our photoresistor. Our two resistors are in series, and we're taking an analog input measurement from port 0 at the point in between the two. And then this second resistor connects back over to ground. So as R1 varies, the reading we're going to get at A0 varies. Specifically, the more light is shining on R0 or R1, our photoresistor, the lower its resistance is going to be. So if I were to take a flashlight and shine it directly on it, its resistance would drop to near 0 or to a very low number. So this point would come very close to reading 5 volts, or the top of its little scale. And as it gets darker and darker and darker, this resistor will increase and increase, and this value, the voltage measured between the two, will decrease. So hooked up this way, I should have something that lights up when the LED should light up when there's light on the photoresistor and go dark when I'm covering the photoresistor. So let's head over to the sketch. So as we head over to the sketch, you'll notice I've got a little bit of the serial window sort of poking out to the left side of the actual sketch window. I've actually made a few modifications to the sketch that I was given because I was having difficulty tuning the photoresistor outputs to actually be something visible and to match with what the program was attempting to be saying. So I've added a few commands in order to give me some serial output to see what the actual read off the analog pins and what the output it's giving is. So the sketch actually starts with defining the sensor pin and the LED pin. So we're going to be reading the sensor off analog pin 0, and we're going to be outputting to the LED through digital pin 9. And they're defining 3 int level, or 3 light levels, or they're defining 3 variables: light level, high at 0, and low at 1023. So first, during the setup, they set the LED pin for output, and then I also include serial begin at 9600 baud. So I initialize the serial output at the same time that they're initializing the pin output, and we move over to the loop. So they say set the light level to whatever analog read at my sensor pin is. So analog read at the sensor pin will return a value between 0 and 1023, where 0 is if it's receiving 0 volts, and 1023 is if it's receiving 5 volts. So the lower the resistance, the higher this light level number should be. And here's where I include serial print light level and then serial print a space. So the first column on my serial output window should be essentially what my analog read is giving me, and I'm going to need that number later in order to properly tune my circuit so that the LED will turn on and off with varying light levels. Now, the program includes two different ways to essentially tune your light level: a manual tuner and an auto tuner. And they're both two different functions which are called out, and you head down to them to do that. But first, we're just going to finish out the actual main body of the circuit. And what it says is write to your LED pin your light level. And analog write is limited from 0 to 225, but light level has been mapped from 0 to 1023. So these various tuning things are essentially going to switch those values from 0 to 1023 to 0 to 255. So the higher the input value at A0, the higher the analog write should be, and therefore the brighter the LED should be. And once again, I include serial print new line light level, so that should show me what it's currently outputting to my LED as well in the second column of my serial window. So manual tuning. The first of the two ways that you can tune this circuit is manual tuning, and it says when you call manual tuning, take light level, which is a global variable, so it's accessible to absolutely any of the functions that are included with this sketch. So take light level and remap light level from 0 to 1023 from a range of 0 to 1023 to a range of 0 to 255. So assign to light level, mapping from light level itself, so taking light level and resetting its own value. Take a range from 0 to 1023 and reset that to a range of 0 to 255 in scale. And then take light level and constrain it from 0 to 255. So if you have a value that is outside that range, shunt it until it is back inside that range. And the reason you'll do that is because these two map values and light level from 0 to 1023, those are what we're going to be adjusting to determine how bright or dim we want the sort of on and off settings for our LED to be. So if we bring this 0 up to 200, then it's going to say once we get to 200, and because we're constraining from 0 to 255, 200 and everything below it are now 0. And if we bring the upper bound down to 800, 800 and everything above it are now 255. So that's how the manual tune works. You adjust these values, 0 and 1023, until you've got something such that when you mess with how much light's on that photoresistor, the LED turns on and off. And that's most of the reason why I wanted the serial window open, because I need to see what values it's giving for when there's light on it and when there's not light on it, so that I can adjust these constraint values and actually have the LED turn on and off. Otherwise, I'd just be guessing and guessing based on the light level of this room until I finally started getting some results, and that just wasn't working. Now, the other way you can have it tune is auto-tuning. Auto-tuning first says way back up at these, you initialized high at 0 and low at 1023. So what auto-tune says is if my light level is currently less than my low value, which your low value is 1023, so pretty much any value you put in there is going to be lower than 1023. Then set your new low to what is currently the light level. And then check the light level. If it's currently greater than the high, which you start at 0, so pretty much anything's going to be higher than that, set high to your current light level. And then basically, those two things are going to say, as the light varies on that, it's going to automatically shunt those floor and ceiling values until they sort of sit in a range that says, until they sit in a range that's from the lowest value it's seen to the highest value it's seen. And then you're going to map light level from low plus 30 to high minus 30, 0 to 255. And the reason you've got low plus 30 and high minus 30 is so that you bring the ranges off the absolute extremes, so that when you get to those extremes, and there's going to be a little bit of flux and waver because the photoresistor is changing depending on exactly how much light is reaching it at any given time, it should be full off and full on at the top and bottom of the scales, instead of flickering as it sort of dances near that value and doesn't stay at either full off or full on. So those essentially are used to cap the limits so that the LED actually goes fully off or fully on at the far ends of the scale. So we're going to start with manual tuning. And if I send this over to the circuit board, LEDs lit up, and for those of you curious, our photoresistor is this guy right here. It's a bit hard to see, but it's this little plate on a stick is our photoresistor. And it's reading the ambient light level in this room at about a value of 255 and mapping that out at about a 63. Now, if I take my finger and I cover this, you can see that the brightness of the LED changes some. And if we go back over to our serial window, we'll see that that value's dropped to somewhere in the 40s to 50s, and that we're outputting about a 10. So if we go back to our tuning, our manual tuning, and we set our minimum value to 80 and our maximum value to 220, sort of a plus minus 30 that they've been shown in the auto tune, and then send it back. Now, at our ambient light level, it's outputting 255, the maximum value. LED's fully lit up. If I cover this, LED fully goes out. My value here is below my minimum threshold, but you might occasionally see a number shoot through the second one where it just jumps over 80 very, very briefly. And you can actually see, yeah, the LED flickers just a little bit when that happens. So perhaps my lower bound isn't quite high enough. But there you go. That's light turns on when there's light on the photoresistor. Light turns off when the photoresistor is covered. Now if we go back over to the sketch, and we've been doing this manual tuning, let's instead go over and let the program do the tuning for us. So we've switched over to auto tune. And now it's outputting 100 something at my ambient light level. So we've got the light on at the ambient light level. And if we cover this, it's sort of twitching and trying to decide what to do. If we uncover it, it gets brighter. But if we cover it, it's sort of flickering as the exact resistance varies between the lower bound. Since my lowest lower bound has gotten very, very low indeed, it starts flickering at this lower level as it actually gets up higher than that 30 buffer rather frequently. You can actually see several values that just flicker above, so the LED is going to flicker a bit here. But if I take my finger back off, it's going to go back up to full 255. So it's determined that the highest value is somewhere in this 240 range, but the low value is something like a 3 or a 5 that's coming to this column. And since this column's also regularly things up to about 60, yeah, the LED is going to flicker a bit, or just generally be dimmer than normal. So for a component like this photoresistor, the auto-tuning might actually be a hindrance if you don't set your buffer high enough, and you'd be better off using the manual tuning if you've done something like this serial output, so you know exactly where your outputs should be in order to make sure that it turns fully on and fully off. Now, there's a slight printer's error or something in my Arduino sketch kit where it has the photoresistor wired in different positions. So if we go back to the schematic here, the printer's error basically switches the position of the photoresistor and the standard resistor, so that instead of the photoresistor being connected to 5 volts and the standard resistor being connected to ground, it's the other way around. And having it hooked up that way is something worth taking a look at. So let's just very quickly wire it up the other way around. So now as the photoresistor gets more and more light on it, it's going to approach no resistance at all. So when there's a whole bunch of light shining on this photoresistor in this configuration, A0 is going to be reading ground. And as less and less light shines on that photoresistor, it's going to start having a resistance, and so the voltage here will rise. And the reason why this might be more useful than what I've currently got is this would be a darkness sensor. This will turn your lights on when it's dark, as opposed to the current setup, which matches the light level of the LED to the light level currently being shown on the photoresistor. This reversed configuration will instead light up the LED brighter and brighter the darker the photoresistor currently is. So, even this sort of mistake that had me tearing my hair out and wondering why it's not behaving the way it's supposed to, actually does have some practical use on its own merit, perhaps even more so than the simple circuit that we've been shown here in this example.